Welcome all to this special webinar event in collaboration with Calicarb, Symphony Natural Health, and FullScript. I'm Amy Regan from FullScript, and I'm so glad you've joined us today. A few housekeeping notes. Please place all questions you have in the Q&A box for a chance for them to be answered at the end of the presentation. This webinar is being recorded, and the recording will be sent via email to all attendees and registrants. There is a copy of the presentation slides in the handout section, and this recording will also be available at fullscript.com/webinars in a few days. Today, we're so glad to be joined by Dr. Holly Lucille, the Senior Medical Advisor here at FullScript. It's great to see you, Holly.
Great to be here. I love this platform. This is great.
Excellent. I love it too. I got to be honest with everybody. We will also have a presentation from Dr. Deanna Minich, who is the Chief Science Officer at Symphony Natural Health, and a presentation from Dr. Edward Walker, a researcher at the New Zealand Institute for Plant and Food Research. So we're excited to dive right into these presentations.
Yeah.
All right, Holly, take it away.
Okay, so of course, this is intended solely for education of healthcare providers, and it's not meant to provide any medical or professional advice to anybody out there. And next slide. And then just a little roadmap. We're going to talk a little bit this next slide about a survey that was done and what we found out and why I think this webinar is so important. And then we are going to have a video presentation from both of our experts. Okay, so that'll last around 48 minutes. So Dr. Edward Walker would come first, and then Dr. Deanna Minich. And then my most exciting part that I'm excited about is the in-app comprehensive menopause protocol that we're going to all go through together. Like, it'll just be interactive. I'll have you log in. Super awesome. And then live Q&A with me if we have time. I do want you to know, if you have questions specifically for the manufacturing companies or the ingredient experts, and I can't get to them, we will make sure that all of your questions get answered, and we will send you an email of that said answer. All right, next slide. So, okay, women are expecting more and tolerating less. So this bona fide state of menopause survey basically gathered data from about 2013 US women age 40 to 65 experiencing what they knew of as perimenopause or menopause symptoms. And it pretty much revealed some key findings. A significant number of women remain unaware of what are early symptoms of this, let's just say, not pathological, but natural phase, right? That we're lucky enough to go through if we are living this long. And a lot of women feel unprepared for this life stage. And the findings also showed that while there's growing openness about discussing menopause, there's still a lack of education and resources available to women. We've got also younger women taking to technology to find different management approaches. And so I feel like we've got some work to do in this area, and that's why I'm so excited for this webinar. All right.
Excellent. So we're just going to do a quick poll. So let me just press start on this, and we're going to jump into the videos.
Yeah, great. So you can obviously do this later, but the poll is right there. How familiar are you with using dietary supplements for managing menopausal symptoms? Very familiar, somewhat, not very familiar, or not familiar, but prefer other treatment modalities, because that's going to help us shape other future educational webinars.
All right, so here we are with the first presentation.
All right, we'll see you on the other side.
All right, so hi everyone, I'm Dr. Edward Walker. I'm a research scientist and lecturer. I work at the New Zealand Institute of Plant and Food Research, which is a government-owned research institute, and I also lecture in nutraceuticals and functional foods at the University of Auckland. So I'm going to talk today about a nutraceutical that was developed named Amarasate. It's a functional ingredient that's been shown to activate a series of appetite-suppressing hormones from the gut, so mainly GLP-1, CCK, and PYY, but also a series of other hormones, and generally sort of shift people towards a pro-weight loss condition from there, or gut signaling condition. So where did this all start? So this research all started in 2009 actually, when we put in a government-funded research grant application to develop a nutraceutical food product to suppress appetite and decrease hunger. Now, I guess the big question here is why did the New Zealand government want to fund this kind of research? And New Zealand's very much the same as America in that we have a pretty major obesity issue. At the time, there were no good drugs really available in the market. So if you can think back 20 years ago, then sibutramine was pulled from the market. So that's one of those sort of almost amphetamine type medications, or was voluntarily withdrawn due to cardiovascular events. And there was another drug which you guys never got in America, but it was an inverse cannabinoid receptor. So think basically anti-marijuana. So that reduced people's hunger, but it also made people, strangely enough, depressed. So it was pulled from the market to around 2005 as well, I think. And then from the nutraceutical side of things, ephedra had been pulled by the FDA in around the same time. So we didn't have a lot of, I guess, good options for weight loss medication. So we thought, well, what about a more natural sort of nutraceutical functional food type approach? And so we did a series of studies. We looked at bitterness in the gut, and we checked to see if there were receptors in the gut. We then did high throughput screening, which was done sort of basically a pharmaceutical approach to develop a nutraceutical. We found a specific type of hop, so Watson beer, that was particularly good at activating that. It went out of around 1,000 different plant extracts. It was the most potent. We then done a series of clinical trials looking at mode of action effects and also looking at behavioral effects, so reduction in hunger, cravings, etc. We're currently undertaking a fourth clinical study, which is 150 men and women looking at mainly weight loss, but also a series of other biomarkers. And the nutraceutical is used mostly around the world, but primarily by obesity specialists as a form of weight loss therapy. So let's get into the story about it. So why did we look at bitter plants and human taste receptors? Well, if you think about evolution, there's almost been a battle going on between humans and plants as to making us eat them, but also making us not eat them. So if you think about, say, an apple tree, what you have is the apple tree wants you to eat the apple, right? But it doesn't want you to eat all of the leaves around it. So what the apple tree does is it makes the apple very sweet and delicious, right? So you go there and you eat it, spread the seeds, but it makes all of the leaves and even some of the bark around it very unpleasant and very bitter. And it does this to prevent you from accidentally eating the parts of the plant it doesn't want. Now it turns out that for apple anyway, there's actually a moderate appetite suppressant present there as well. So not only does it taste bad, but it also suppresses your appetite. So there was this history of using plants, or evolutionary history of using plants to suppress appetite. That's what they want to do in people. There's also a lot of human history of this as well. So if we think about what happens in various cultures around the world, if you look in the Kalahari, they will use a bitter cactus to suppress appetite during times of hunting trips. In the Highlands of Scotland, they used to use a bitter heath pea to suppress appetite during times of famine. And Vedic and Chinese medicine also use bitterness for diabetes control and also for obesity management. So we're using bitterness to basically trigger a system in the body which is preventing accidental poisoning. So bitter systems are there to stop you from accidentally poisoning yourself, because bitter compounds can potentially be poisonous, but you can also activate them with food that is not poisonous. On your tongue, it makes you want to spit it out, but it turns out we actually have gastrointestinal bitter taste receptors. So as part of this project we ran, we actually did a biopsy-based study in the hospital where I went in and did basically got 30 people to give biopsies all along their intestinal tract to see whether we had these bitter taste systems present. And what we were able to find was that they were present out of the 25 bitter taste receptors humans have. Now, we got all of them on the tongue. 17 of them are present in the small intestinal tract, or the intestinal tract of pretty much everyone. And so what that means is that they're a viable target. They're also elevated in the fundus of the stomach, where the gastric fluid sort of floats, and also in the terminal ileum, which likely relates to functions for detecting bacterial overgrowth and detecting accidental consumption of very bitter foods. So would these gastrointestinal bitter taste receptors, would they stimulate the release of appetite-suppressing hormones? And the answer to this is yes. And so in order to figure this out, we took the cells from the gut. So these are enteroendocrine cells, and these are the cells that express the bitter taste receptor. So if you look at the figure to the top right, what you'll see is that there's a thing called a TAS2R. Now that's the name for a bitter taste receptor. They're called TAS2Rs. And when they're activated by a bitter compound, what they do is they trigger a series of internal signaling molecules, primarily looking at increases in, or the release of, calcium, or intracellular calcium as a marker that they've been activated, and then that calcium will then trigger the release of an enteroendocrine secretion. Now, what that secretion is, that's basically the hormone they contain, and it depends a little bit of where they are in the gut, but in the case of the cells we use for our high-throughput screening in the lab, they contain GLP-1 and CCK, so two major appetite-suppressing hormones. So what we were able to do is we were able to get basically 1,000 different plant compounds and extracts, and we screened them against these enteroendocrine cells in the lab, so really taking a pharmaceutical type approach. And we could show that the hormones, or the hormones, would be released in response to a few of the compounds, to be honest, not many. So out of the 1,000, we got really about 4 viable plant extracts that would work. 2 of them were unstable and 1 of them wasn't really suitable for consumption. So we ended up just with Amarasate, which is a type of hop, which is exceedingly bitter. And so we took that forward and really looked at what the bioactives were and whether it caused what you call a dose response. Now, the dose response for CCK, which is one of the appetite-suppressing hormones, is in the bottom right here. And this just shows as you increase the concentration of the Amarasate hop extract, you get more CCK coming out. And this is just showing you that, yes, it's a real effect. It's not just that the cells are being damaged and causing a release. So the next question is, well, does it work in people? So it's really quite easy to get enteroendocrine cells in the lab to release their hormones. So all you have to do is basically stress them enough that a few of them will burst, and then the hormones will come out. So it's really important that you validate results in people, right? So if you ask me, you said, we want something which will cause an enteroendocrine cell in the lab to release some CCK or some GLP-1, I'd say, well, you can do that easily, and you can do it accidentally if you're not careful. But to get a meaningful result in people is really, really tricky, right? And so what we wanted to do was really say, can we get a meaningful, biologically important increase in these gut hormones in people? And so what we did was a 3-treatment double-blind crossover study in adult men, and here's the 2 main treatments shown on the figure here to the right. And what we did was we gave the Amarasate hop extract an hour before we gave an eat until you're full lunch, and then an eat until you're full snack, right? So they're basically given the capsule, and then they're given a eat till they're full lunch, eat till they're full snack, and we measure how much food they eat. During that time period, we also measured what was happening to their gastrointestinal hormones. And so here's a GLP-1 figure here. And what we can see is that when they're giving the placebo capsule, you get a normal response to the lunch. So you get an increase in GLP-1. It's what normally happens. a decrease over the next couple of hours, then a small increase at the snack, and then a decrease again. And that's the exact normal rhythm that GLP-1 will follow in your body, and that increase is around sort of a threefold increase. And again, that's exactly what you'd expect from a normal eat until you full meal. Now, if you give the Amarasate extract about an hour before the meal, what you find is that there's an increased GLP-1 response, and that response is prolonged. And then it lasts into the snack as well. And the longer, actually, it's more pronounced in the snack. So you can see that the difference in GLP-1 increase in the snack is much greater than in the placebo group. When you're giving the Amarasate treatment, it's much greater, and then it lasts a little bit longer too. Now, this is really important because we're pushing GLP-1 and also CCK, which the results are very similar for, right into the biologically active range. So there's sort of a rule of thumb that a meal gives you threefold increase in GLP-1 and CCK, and that's enough for normal biological effects. If you want to get something that's bioactive, so you're getting effects on appetite, effects on food intake that are in addition to what you'd normally expect, you need to be over 4.5 fold. And so we're getting 6-fold, so we're well into that biological bioactivity realm, and so we'd expect behavioral changes. And so this becomes even more impressive when we look at what happened at those meals. So since they were an eat till their full meal, we could actually see that people ate less at the lunch, and significantly less at the snack, and then less at the 2 meals when they were combined. So what we're saying is we're getting more of these appetite-suppressing hormones, even though people are eating less food. So we're driving them to eat less food, and we're still getting more of the hormones. They're basically feeling fuller from less food. So how does it work? So Amarasate's delivered in a time-release capsule, and the objective is to get it to the small intestine. So all of these hormones, the appetite-suppressing hormones, whether they're CCK, GLP-1, or PYY, they're all found in the small intestine. And so what we want to do is we want to release it there and create a high concentration where it can progress down through the gut and stimulate the release of these hormones. So initially, the delayed release capsule will release just as it leaves the stomach and trigger CCK. It will then progress further down the gastrointestinal tract and then trigger GLP-1, and it will also trigger PYY to a lesser extent. Now, for those of you who are looking at the anatomy, you might say, well, how can it trigger PYY so quickly, because PYY is quite far down? Well, what we actually find is that the CCK signals PYY to be released. So you sort of get CCK triggering PYY. So even though PYY is further down the gut, you can still trigger its release with a upper small intestinal stimulation. Now, this will last for about 4 to 6 hours. Now, it is a little bit more variable between people. And so what we can find is that for some people, this will last all day. So you'll get one treatment and they'll feel the effects for a long period of time. But for most people, it's around 4 to 6 hours, and it keeps working as it moves down the gut. So the Amarasate nutraceutical hop extract is not very bioavailable. So animal studies indicate that as little as 1% is absorbed into the blood. And so what that means is it's staying in the gut, it's bioactive as it progresses down, and you don't have to worry too much about absorption into the blood, interaction with drugs, and stress on kidneys and liver. All right, so does Amarasate control hunger and appetite? So we had this, amazing result in that we had huge stimulation in these appetite-suppressing hormones, and to be fair, really, there's nothing before and nothing since has come close to that sort of level of stimulation. And we had a reduction in food intake. But one of the questions we hadn't answered was, are we actually regulating hunger, and are we regulating, like food cravings? And so these are really important drivers of food choice. So the previous study, we'd given a fixed meal, but we hadn't given people like a choice of what food they can eat, like whether it's, a poor food choice or a good food choice. So in this study, we wanted to make people basically really hungry and test not only whether we could knock their hunger down, but whether we could knock down their food craving. And so what we did was basically 2 clinical trials. One was on males and one was on females. And we got them to fast for 24 hours. So 24 hours of fasting to make them hungry. We brought them into the lab at 16 hours into the fast, so they had no food for 16 hours, only water. And then we gave them the Amarasate capsule at 16 and 20 hours into the fast. And we were just looking at that change in hunger and change in food craving they had over that last 8 hours of the fast, hoping that we could, reduce it. And so what you see here is you see for the food craving, which is the figure on the top right here, that this is in the female population, that they were actually craving food at 24 hours into the fast less than 16 hours into the fast. So they were craving food less at the end of the fast than when they first were given the Amarasate extract. And that compares to if they were given a placebo, where their food craving can continue to increase. So what's, I guess, important here is that this is the change in food craving. So they're already craving food quite a lot here. So that's the difference between craving food a lot and craving food, just like a huge craving. So it's basically as much as you can get. And this is knocking it down from, I'm craving food to, I'm not really craving food that much. And this is a result we hear a lot when people are, if you give someone the Amarasate extract, a lot of what they'll say is that, I'm still hungry and I still eat food, but I'm having an ability to make a food choice that I want to make. If we look at the hunger data, it's reasonably similar. The hunger increase in the placebo group from 16 hours to 24 hours into the water-only fast. And as you'd expect, a big increase in hunger over that period of time. And these 2 sort of increases, you see an elevation around here, 2 increases. So if we look at the hunger value, what you see is an increase over time from 16 hours to 24 hours in the placebo group. And there's 2 periods when that sort of jumps up, and that's around lunchtime and around snack time. And that's what you expect. People are accustomed to having meals at certain times, and that's when their hunger will increase. But what we've done with the Amarasate treatment, and it's just completely flatlined it. So they've basically had no further increase in hunger over that last 8 hours of the 24-hour fast. And again, that's the difference between people going from, I'm a little bit hungry, to I'm absolutely starving, to I'm a little bit hungry, I'm still a little bit hungry. And again, that's something that allows people to make a healthy food choice. We also gave the females a post-meal, a post-fast meal, and where they eat till they were full, and we found that they ate 14% less food. So not only were they feeling less hungry and craving food less, but they also acted on that. So they also ate less food. So that's really important. The other thing that we noticed in the study was if we looked at the craving for sweet food immediately after they eat till their full meal, even though they were eating less food, they were also craving sweet food less after the meal. So if you think about craving for dessert, etc., there was less of that. That was really, really important. So how do you do dosage? Now, one of the great things about having a gut target is that the gut target is the hormones are really bioactive, so you can get amazing effects. Because you're targeting the gut, you've got a degree of safety. You don't have to get into the blood. Like I said, you don't have to worry about drug interactions. The downside is that it's a little bit more variable between people. And so you tend to have to maybe optimize the dosage a little bit. And so this comes down to really understanding how the product works and understanding, how to give it to people. So because we're trying to get this through to the small intestine, you need to give it on a relatively empty stomach, and you need to give it at least an hour before someone eats food. So what you don't want to do is you don't want to either take the capsule and have food in the stomach, because it's a delayed release capsule. If there's a whole lot of food there, it will open in the stomach, not where you want it to, in the small intestine. Or if you take the capsule, then have food immediately on top of it, that again will delay it in the stomach and make it more likely that it will open in that area. So you need to remember, take it, an hour before a meal, relatively empty stomach. And we also suggest that you dose up the amount. So here's a sort of a model titration. So you start off in the morning with 125 milligrams. That's one capsule. Again, an hour or so before a meal on a relatively empty stomach. And you do that for a couple of days. You then increase to taking it twice, again, before your sort of major, probably morning meal and evening meal, an hour before them. And then you'll do that for a couple of days, one capsule before each meal. And then on day 5, you can do 2 capsules before each meal. Now, this is sort of the default protocol, but there are people who'll be more sensitive and less sensitive. So if you think about an average user here, you can see that they're probably good on day 5 to have 125 milligrams before a meal. But if someone is not very sensitive to bitterness and they're not really feeling the appetite suppression from 125 or 250 milligrams, what you can do is you can increase the dose. So there's not really, we haven't observed any safety issues with this. It's a relatively safe product. So we would expect that going to 375 milligrams an hour before a meal is fine for those people who aren't showing much sensitivity. And then there are people who are very sensitive, and this will vary a little bit, but like I said, some people will have one pill a day, and that's all they need. If you're someone who has increased levels of sensitivity, then you may look at, having some side effects, so you decrease the dose, and you 125 milligrams an hour before a meal. So you just basically stay on the day 3 dosage for those people. So how's it used in clinic? Well, so here's Dr. Ben Gonzalez, and he's been kind enough to share his ways of using Amarasate in his clinic. So he basically has 3 ways of doing this. One is in adjunct therapy with the GLP-1 receptor agonist. So that's when you basically look at giving the GLP-1 injectable, but also giving the Amarasate extract. And the reason for that is to try to decrease the amount of the GLP-1 injectable you need to use, because the Amarasate will not only keep your gut releasing some of its endogenous GLP-1, it will also kick in and help with some CCK and some PYY, which will decrease the amount you need of the GLP-1 receptor agonist. Another way he's using it is to transition people off the GLP-1 receptor agonist. So that's obviously a big concern for people when you've been on the drug for a while and you've achieved a weight loss you want. You're faced with the option of either staying on it forever or risking weight regain. And so what Ben's been doing is he's been tapering them off the GLP-1 injectable and putting them on to Amarasate. And he can use that, to basically maintain their weight loss while he's taking them off the drug, or using it as a primary compound with lifestyle change. So no receptor agonist, just giving the Amarasate. Okay, so this is a big thing, transitioning off the GLP-1 receptor agonists. So what he'll do is he will give 125 milligrams in the morning. So this is a sort of a modified version of what we suggest. 250 milligrams prior to the largest meal of the day. If someone is snacking late at night, so if they have a problem with late night snacking, he'll give another 125 milligrams in the evening. So 1 capsule in the evening later on to knock that snacking craving on the head. If it's well tolerated, then he can increase it to 250 and 250. So 2 pills in the morning and evening. And there's also the option of having that 125 extra if they snack at night. And he said you can use it, maybe use while you're using the GLP-1. So the same approach can be used when someone's on the GLP-1s to lower the amount of the GLP-1 injectable they need. And Ben says he uses Amarasate in all of his metabolic repair programs. And so I think this is a really good point, is that it's not just about appetite control and weight loss here. What the Amarasate extract is fundamentally doing is restoring your gut's ability to signal to your brain. So we have a really reduced ability in modern life of having gut signals. We don't have great diets where our diversity is way down. And so what Amarasate does is it just gets all of those gut signals going back to your brain, and it helps with not just things like weight loss, but also insulin control. We see data on better glucose levels, etc. So it's really a very useful product. And of course, Ben says that you have to do it with proper diet and exercise, protein intake, and amino acid supplementation. So this is true for, any of the GLP-1 injectables. It's true for Amarasate as well. If you look at the data for GLP-1 injectables, when people are not well managed, then the weight loss is not that great. Yeah. So here's a case study which Ben has shared with us, and this is Kate. So it's quite an interesting one. So she came in to see Ben in 2009. She's type 1 diabetic with who's an athlete who wanted to have some fat removed from her abdomen. So she had additional abdominal fat. She was so 175 pounds and high blood glucose, and had an insulin pump installed, and was kind of annoyed with the way that the endocrinologist and the medical system was treating her. She wasn't feeling like she was getting a good outcome from the medical system. So what Ben said is she had a look at her. She had irregular menstrual cycles. Her blood sugar was kind of everywhere, and she was putting on weight. And this is where it gets really interesting. If you look at her blood tests, there's no testosterone, there's low DHEAs, and the vitamin D was low as well. So those are not usually associated with a 27-year-old woman. They're normally what you'd see more in someone who's post-menopausal. So he managed the diet, macronutrients, and hormones, and managed to get the weight down, and the HbA1c dropped. But then what happens is she moved away, went off the treatment, back to sort of normal management care, and weight went back up, HbA1c went back up, wasn't feeling good. So she came back 8 months ago. Ben put her on semaglutide, and there's some references for using semaglutide in type 1 diabetics. And he started Amarasate at the same time, and the GLP-1 receptor agonist stopped at 3 months in, so he transitioned off the GLP-1s with Amarasate. And what he managed to get was her HbA1c is lowest it's been. Her weight is low, and it's pretty stable, and continuing on Amarasate to maintain that weight loss. So that's basically it from me. Here are some of the references. And if you have any questions, you can always email me at edwardwalker@plantandfoodresearch.co.nz.
Hello, everyone. I'm Dr. Deanna Minnick, the Chief Science Officer at Symphony Natural Health, and I'm delighted to talk with you more about Maca-GO for women's hormone health. As the name suggests, Maca-GO has something to do with maca, but if you go to the first publication listed here on the slide, this is from earlier this year, 2024. This is a paper that we wrote, and the title is Not All Maca is Created Equal, a review of colors, nutrition, phytochemicals, and clinical uses. And the paper highlighted that there's a lot about maca that isn't commonly known, and it continues to evolve. First and foremost, there are up to 17 different phenotypes of maca described in the literature. And those phenotypes of maca can have a different color, different DNA, different analytical profiles, and most importantly, can elicit different physiological effects. As an example, we have found that there's one type of maca which supports fertility in men and a different one for supporting fertility in women. There's one for helping to reduce cholesterol and the others don't, two that affect bone mineral density and the other ones don't, and one that is extremely helpful for menopausal symptoms and the others less so, which is why from a clinical perspective, it's extremely important to know the type of maca to use for the desired therapeutic application. The reason for the different effects is in part due to how different phenotypes nourish or support different systems in the body. Some are more impactful on the adrenals, while others have a greater impact on the hypothalamus and the pituitary. So when it comes to the standard kind of maca you find at the grocery store, often in a powdered form for smoothies, you will find that it consists of all of the different phenotypes mixed together in the natural ratios that they grow in. Now, this type of maca combination may be good for adrenal health, but when you're looking to support the entire hypothalamus, pituitary, thyroid, adrenal, ovarian axis, which is the HPTAO axis, it isn't ideal. In fact, it may even be the wrong type of maca. And the perfect example of that is with PCOS and estrogen dominance, in which you find that if you give these patients this normal standard maca, it can often worsen symptoms like acne or hair loss. But when you look at products like Maca-GO, which nourish that entire HPTO axis, it might actually improve the hormone imbalance for women with those conditions. And we do know that to be true. So the key takeaway is that just by using the right or the wrong phenotype of maca can lead to healthy or harmful effects. It can be the difference between whether a product works or not. And the other point is that it's not just about the color. I know that I'm showing 3 different colors of maca here in this photograph, but it's also about where it's grown. The soil, the elevation, and weather, as well as how a crop is harvested, dried, and manufactured, can all impact the analytical profile of maca. If you want more detail on that, you will see the reference listed below from 2020. And this is where Symphony did a joint study with the American Botanical Council, the USDA, and the NSF. And what that study highlighted, which we had known for over a decade, was that the location where maca is grown has an even greater impact on composition and thus function than even something like color. In fact, location is so important that we have grown our maca for men and women in different regions of Peru for 15 years. So location is essential to know. When it comes to all herbs, concentration and bioavailability are critical to ensure a therapeutic efficacy, and maca is no different. What you might find interesting is that raw maca is only about 68% water soluble. It can be hard to digest because it has a high starch content. And this is why you will often see maca as an extract or gelatinized. Gelatinization is where you combine water temperature and pressure. However, as you can appreciate, using too much or too little of any of those can be the difference between optimizing efficacy and bioavailability or destroying key active constituents through that heat and that water pressure. So Maca-GO is gelatinized through a proprietary process to optimize digestion and bioavailability, and it's been shown to be 99% water soluble and also low in FODMAPs. What you will also notice in Maca-GO is that it has one of the highest concentrations of key active constituents as compared to the strongest extracts on the market. So glucosinolates are a prime example where you will see we compared Maca-GO to the highest concentrated maca extracts on the market. So if you look at this figure, columns 2 and 3 are a 10-to-1 extract from the US, and column 4 is a 5-to-1 extract from Europe. And you will see that there are 2 families of glucosinolates in maca shown by the 2 lines or those 2 bands in the middle. However, as you can see here, each company concentrated a different family of glucosinolates, while Maca-GO, as seen in columns 1 and 6, not only had both families of glucosinolates, but more of each. So the combination of specific phenotypes to support the HPTAO axis in a highly concentrated and bioavailable form is why Maca-GO has superseded all other maca products in published clinical trials. And to date, it's the only maca product with published clinical trials demonstrating statistically significant effects on hormones in peri and postmenopausal women. In fact, the results and level of clinical research is why Maca-GO was the first natural product allowed to be presented at ACOG and also at NAMS, which is the North American Menopause Society's annual event, as well as our research was featured as an abstract and published in their medical journal, which is called Menopause. Now, this is the exciting part for me. As a scientist, I always think about mode of action. So, what pathways is that nutrient or ingredient working on in the body? With Maca-GO, it's one of the most unique mechanisms in that it supports the full HPTAO axis and the biofeedback pathways of hormone production. It is why the studies on Maca-GO are the only to show an impact on hormones in postmenopausal women and both increases and decreases on endogenous hormone production depending on what her body needs. And that's compared to the standard maca that we were talking about and the many adaptogens out there which simply impact the adrenals. So, Maca-GO is not a phytoestrogen. We get that question a lot. So, it's not like soy isoflavones. It's not like red clover. It's not working on estrogen receptor sites. Instead, again, it's affecting the endocrine axis during a time of life when this axis has declined. It's been dysregulated. So, the other mode of action that you might find of interest is that because of its high glucosinolate content, it may also help in the metabolic detoxification of hormones, which is essential because an imbalance of those hydroxylated and methylated metabolites may even be part of that underlying root cause of symptoms in menopause. So, you get two different modes of action, and in combination, this is quite unique. So, as I mentioned before, Maca-GO works on the full HPTAO axis, balancing and regulating hormone production. So, let's talk about the hormones and the findings of the clinical trials. So, this is in postmenopausal women. And what you see is in the first graph, a statistically significant effect on estradiol over the first 3 months. And then it plateaued at an optimal level based on the woman's biological stage of life, as opposed to the placebo, which would be the gray bars, where we saw no significant shifts. Now, the reason I use the term optimal level based on a woman's biological stage of life is because in some circles of thought and in clinical work, there's a push to recreate hormone levels in postmenopausal women of a 30-year-old. So that's not what Maca-GO does. It is keeping within the biological range for that woman. One thing I want to highlight is that as a functional medicine practitioner and advocate for addressing root cause, that's after all one of the tenets of functional medicine, I don't think Maca-GO is a silver bullet. However, what I do believe is that Maca-GO is the perfect start and offers a safe, natural solution to support the body's own production of hormones. Now, for many women, that might be enough. However, if it isn't, then there can always be the easy small adjustment by adding low dose exogenous hormones to get them to the level you and they want. It also offers a solution for those women later in life, be it in their 60s, 70s, or beyond, who want to start to support their hormones and don't want to introduce any to their body. Now, the second panel shows that Maca-GO also impacted FSH. However, as you can see here, it reduced FSH to an optimized level for a postmenopausal woman, again, then plateauing, similar to the estradiol levels. And what I find most interesting in this graph is that in much of the medical literature, an FSH level of 30 and over 30 is a biomarker which signals that a woman is menopausal. And what we see with Maca-GO is that while it reduces FSH significantly, it again optimizes hormones based on a woman's biological stage of life. So again, you don't all of a sudden have a postmenopausal woman with an FSH level of a 30-year-old. The next slide shows the results of our perimenopausal study. And again, you see the strong impact on estradiol as well as progesterone. As we know with perimenopause, hormone balance is about balancing all of the hormones in the woman's body, not just one. So you'll notice here that in this study, we did a placebo crossover where patients were given Maca-GO to start, and then they saw a positive impact on hormones. And then without knowing, the subjects were switched to placebo, where we saw drops in those hormones. Now, I just want to point out that while we originally in 2006 exclusively used 2,000 milligrams of Maca-GO for perimenopausal women in that first clinical trial, but since then, through further research and clinical experience and feedback from the medical team, we have updated the formulation to combine Maca-GO with a much higher concentration of a specific phenotype we have seen that is ideal for menopausal symptoms. And then we also reduced the daily dose to 1,000 milligrams. Now, that said, please note that there will still be some percentage of patients, probably about 20%, who will still need the higher dose of 2,000 milligrams per day for stronger support. So when it comes to menopausal symptoms, and this is why most people go to see you, they want relief from the whole spectrum of symptoms. One of the most unique aspects of Maca-GO is how it impacts all symptoms. Most herbal formulations only impact a third of those symptoms, primarily hot flashes, night sweats, and mood. However, because Maca-GO truly impacts hormones, we saw a great reduction in symptoms and an impact on many symptoms. Things like libido, vaginal dryness, sleep, energy, and anxiety. And you just don't see this in natural products that don't impact hormones. In addition, you'll notice that Maca-GO had one of the highest success rates of any natural product, working for 84% of postmenopausal women and up to 82% of perimenopausal women. And these results were seen within just one box of use. However, it's important to note that in our trials, the women saw results on average within 21 days. But there was a range between 2 days to 8 weeks because every woman's body, of course, takes a different amount of time to recalibrate and even different doses to rebalance their hormones. When it comes to bone health, I think that many of our patients are not aware of how important hormones are. We've all done a really good job of explaining what calcium, magnesium, vitamin D, vitamin K, and other vitamins and minerals we need do, not to mention things like weight-bearing exercise. However, when we look at hormones, our patients overlook the fact that we lose 7 to 10% of our bone mineral density in the first 3 to 5 years of becoming postmenopausal. So within that time frame, is she eating less calcium and magnesium? No, not necessarily. Does the amount of sunlight that she goes in and the amount of physical activity change? Not necessarily. So why is there this huge loss of bone density? Hormones, right? So in the study on Maca-GO in early postmenopausal women, we saw increases in bone density within the first 4 months, while what you will see is that the placebo group naturally saw reductions in bone density. The last panel here is serum calcium, in which we saw increases, which we also saw with iron and some other minerals. Heart health. Now, the connection between hormones and heart health is another aspect of health knowledge I don't think that many patients truly understand. We know that heart disease is the #1 killer of women. In fact, after the age of 50, nearly half of all deaths in women are due to some form of cardiovascular disease. And in fact, once women reach the age of 50, which is about the age of natural menopause, which we typically say 51 to 52, their risk for heart disease increases dramatically. So there's also the connection between lipids and estrogen. So in the research on Maca-GO, we not only saw statistically significant effects on hormones, but like bone mineral density, we saw that this impact on hormones was so significant that we saw other health biomarkers move. So in these graphs that you're seeing here, we see the impact on increasing HDL cholesterol, reducing triglycerides, and even favorably impacting body mass index. There were also favorable impacts on reducing LDL cholesterol. So overall, there were clinical movements in the direction of heart health for menopausal women. When we look at the dose of Maca-GO, it's required to take 2 doses per day to support the natural hormone flow throughout the day. And both of those doses need to be taken away from meals. Now, something I want to point out in relation to dosing is that, as I mentioned, we saw an 84% success rate with Maca-GO. However, that increases to 95% when working with a practitioner and when we can adjust the dose. So, for example, if a patient starts Maca-GO and their symptoms get worse, such as more hot flashes or headaches, that is actually good news. because it means that their body is immediately responding to Maca-GO, but they are taking too high a dose for their body and it's overstimulating the system. In that case, what they should do is reduce the dose to half of what they were taking, and then they should see a dramatic improvement just very quickly. You'll also see here that we mention a maintenance dose. What's important to note here is that often women will see symptoms go away quickly in 3 weeks. However, you will also get some of those patients who come back after 4 to 6 months complaining that their symptoms are coming back, thinking that they should increase the dose, or maybe that Maca-GO just doesn't work anymore. And remember, this goes to the mode of action. Maca-GO can improve relative hormone balance by improving the HPTAO axis function. And that can happen within weeks to help to reduce symptoms. However, it can take a full 4 to 8 months to get into complete hormone balance. It can take a little time. But at that stage, if you're taking the higher dose, it can again overstimulate your newly established healthy balance. So it's essential to reduce the dose to a maintenance dose. Now, other features to note here, because Maca-GO has been shown to increase hormones, we recommend not taking it in conjunction with hormone-suppressing medications. However, it's up to the health practitioner's discretion whether to have women taking it if the patient has had a history of hormone-dependent cancer. Finally, I'd like to wrap up with a published case history on a patient who used Maca-GO who was surgically post-menopausal. So this was a 32-year-old female with a history of hormonal imbalance, presenting with hot flashes, night sweats, anxiety, and mood changes. And her treatment plan involved a personalized nutrition plan, Maca-GO, targeted nutrient supplementation, lifestyle recommendations. And what the outcome of this case was favorable. In fact, there was safe and effective reduction of hot flashes and anxiety in 2 months, as well as improvement in mood and sleep. So again, I feel that this again highlights the unique mode of action of Maca-GO in supporting the HPA axis. And it can be a foundational tool to add to an integrated, functional, holistic protocol for hormone health, together with things like nutrition and lifestyle. Now, there are other case reports that we have because clinicians like you have approached us to tell us about the different patient stories that you've had. So we do have others on PMS, PMDD, and even PCOS, and we continue to have more coming out. So we have provided a reference list of our clinical work, as well as we've got case reports which can be made available to you through our clinical toolkit. And finally, you can scan this QR code to get some more information on Maca-GO. Lots of information, all very exciting. And what I find really interesting is that we are living in a time when menopause is at the forefront, and so many women are seeking very safe and effective solutions. So I feel like this is the time for Maca-GO. So I look forward to hearing more about your patients experiencing relief through the menopause and their experience with Maca-GO. Thanks so much for your time and attention.
All right, thank you for both of those incredibly smart and lovely hosts of the and giving us the information on these evidence-based products. I'm going to ask Amy to come back on the screen here, and this is where, if you would, I want this kind of to be interactive, right? So if you could log into your FullScript plan, we're going to show you how to access the protocol in-app. And okay, so here we go. If you can just do that, we'll give you a second or so. But if you're here at the home page, then you're going to log in and then go to plans. Now, just FYI, this is a demo. So any person that you are looking at, it's not going to be a real person. We're not going to get in trouble for any HIPAA violations or anything like that. Go to templates. There you have it. And then go ahead and search. We're just going to search menopause because that is exactly what we're talking about right now. And then there you have Made by FullScript. Obviously, you can make your own in-app as well. And you can click on that there. And then you can take a look at it all, but go ahead and add it to the plan. You'll see the preview, and you're also going to be able to see the products that are based on the evidence. All right. So there you have that. And then you add to plan. And then when you go up to review the plan, that is your ability to go ahead and send a message there. And of course, this is also where you can customize it. You can swap in some things, you can swap out some things, you can change the duration, you can change the dosages. And then finally, after everything is clear for you, you can go ahead and send that on to your patient right there. Just send a patient. It's as easy as that. Yay. So that is the menopause support template. And then, of course, we've got those specialized ingredients that we just went over. So those ingredients based on the evidence and other foundational things like this next slide are going to be in app. So ashwagandha has some great evidence behind it: calcium, vitamin D, magnesium, collagen. Those are your foundational ingredients when we're thinking about menopause. But of course, all you smart practitioners, you know, we're looking at whole person health here, right? We also know that the built-in backup system for pre and post-menopausal hormone production are those adrenal glands. You know your patient stories better than we do in just a generic webinar. And so these are foundational ingredients based on the evidence, and then those specialized ingredients as well. And they can all be found in the template in the app. And again, 100% customizable for you, so we can practice individualized care and whole person health. All right, so here's where we're going to get to the question and answers. I know we're about 4 minutes to time, and there have been some very specific practitioner questions. And I know Dr. Minnick personally, and I think those we are definitely going to get over to her, and we will have those questions answered for you and then also emailed to you. Okay, but there's a couple of them that I think I want to take up. So can you touch on or share a list of medications we're using these compounds? And this was during the aromatase presentation, that they would be contraindicated or reactive. Whoops, we got a demo here. I'm gonna do it later. I don't know if that poll came up for you, but it came up for me. So I would say, because I was just thinking that particular Amarasate, I should say, that particular ingredient comes from hops. And as we well know, hops is estrogenic. That's where we see the moobs perhaps, or the beer belly. And I would be careful in any estrogen-driven diseases like estrogen positive breast cancer or any other estrogen-related cancers as well. That would probably be one of them. And then the next question, and again, the good doctor gave us his email. So we're going to get any outstanding questions answered for you straight away. But there are genetic variations in the TAS2RS, and I think that's the bitter taste perception, I believe that is. And so when he was going through the presentation, he said some people are different, and there's variations. And so I bet you that genetic variation has something to do with that, and that's where the dosing can be different for that as well. I think some other questions are coming into, and again, these are pretty darn specific. So we're going to get these questions over to the manufacturing companies and their experts and get them back to you. But on behalf of Fullscript and Emerson and Amy and I, thank you so much for joining us. I think the survey that Bonafide did was pretty enlightening. I know as a menopausal woman myself, and my patients and friends especially that call me every day, like, what can we do? We know that this is a very natural phase, right? I think we want to be careful to not pathologize it. We know that postmenopausal weight gain is probable, but it's manageable. And now we've seen that we've got some other tips and tricks to help do that. And I think education and really facilitating understanding for these women going through menopause in our modern day. I think our modern day influences are really affecting how we transition through this very once honored and powerful stage. And so I know we have the tools to do that as well. So Again, on behalf of FullScript, I'm Dr. Holly Lucille, and thank you so much for joining us.
Thank you, everyone. If anyone has any questions, of course, you can reach out to me. My email address is amy.regan@script.com. And I just want to say thank you so much to Dr. Holly, and lovely spending the afternoon together. The recording and the handouts will be available a couple of days after the webinar and will be sent to you via email. So look out on your email for that. And thanks so much, everyone, for your time today. Really appreciate it.